Okay. So if I go to this guy here, and I'll switch to our thing. Let's just go to my projects. Yeah, see, I have it in here now. So this is the correct one. So if I make a quick change here, yeah, see when I hover over this, it says Control S to save it. That doesn't actually work on the Mac. I'm sure it's not Command S. Yeah, the Command S saves the screen. So all along, I mean, I have a pretty good habit when I'm coding to save, even though things typically save for you. I promise I'm hitting save all the time. And then you got me thinking, last class or the class before, saying something along the lines like, I think you just forgot to save. And then when I did some software update in my office the other day after class, and everything we did during class was just gone. So I just rewrote it. So I maybe wrote it a little bit different, better, whatever. But in any case, this is the code that is currently up there, and I think I'm displaying the final state of our guy here. I think pretty much what we had was fine. I'm trying to remember what the bug was. It was just something fairly small. It had to do with the parentheses. Oh, I remember what it was. It was actually a bug in our linked list itself. When we're processing through this guy and we hit 2 operators in a row, it was putting in a empty string, because every single time we hit an operator, we store the current token we've been building up and then store the operator. Well, when you have 2 operators in a row, the number you've been building up is the empty string. So you kind of have to say, is this the empty string? If it is, don't store that. That means you had 2 operators in a row. I guess when we originally wrote it, it's reasonable for us to say, well, I can't imagine a situation where we'd have 2 operators in a row, because when we wrote that tokenizer, we were operating off a pretty simple math expression that didn't have parentheses and things like that. So that was the issue. And then the thing was crashing or having issues when it got to that empty string and was trying to make decisions based on it. All right, but in any case, here is our output queue. So the final step is now to do the math based on that. Do I still have Shunting Yard open? Okay. All right, we're not going to go that far with like sign and things like that. But now we want to actually process our output queue. Well, we'll just. All right, so if we have something like this, we know that what we should be doing is we should be doing the 1 minus 5, taking it to the second power, taking it to the third power, then doing 2 divided by that. Yeah, and then doing 4 times that. Actually, it'd be left to right. So doing 4 times 2, which is 8, 8 divided by whatever this is, and then 3 plus that is what our final answer should be. So that should be -4, 16. What's 16 to the third power? That is 4096. 8 divided by 4096 is that. That's kind of a crappy number. +3. 3 point something. All right, so that's our, yeah, that's really kind of a weird example. I guess I just wanted to throw all the operators and stuff like that in there, but at least our math was right. So the Mac agrees that's how you do the math. All right, so now we need to look at how do we actually accomplish doing the math here? Because remember, this is our output queue. Okay, so this effectively has staged all of our things in the order that we should deal with them. So we're going to start peeling, and kind of makes sense here. We just see the very last thing we should do is that addition, which kind of makes sense. You know, this is the weakest of all this stuff. All right. So what we need to do is we're going to do this math based on a stack. So let me kind of show this to you. I'm going to steal this. Let's open up Keynote here. This is 300, right? What am I doing? Okay, this guy right here. All right, so we have something that looks like that. So I'm going to treat this guy down here as a stack. Okay, so as I start processing this guy, I'm going to I'm going to remove from the front of my output queue that 3. I'll push it onto the stack. Now I hit a number. I'll remove the 4. I'll push it onto the stack. I hit another number. It's the 2. I'll push it onto the stack. Oops, sorry. Then I hit the multiplication. Since I just hit an operator, I effectively do the math. So I'm applying multiplication to the pop of these guys. So I pop the 2, I pop the 4. 4 times 2 is 8. And I push the answer back on there. All right, so just to see that, I remove from the front the multiplication here. I notice this is an operator. Since it's an operator, I need to do some math. What math am I doing? I'm doing multiplication. What am I doing it to? The top 2 things on my stack. Make sense? So I'll pop the 2 off, I'll pop the 4 off, I'll perform the math, and I'll push the answer back on. That gets me that 8 there. I remove the next one, which is a 1. It's a number, push it onto the stack. Next one is a 5. It's a number, push it on the stack. Next one is a minus. Since it's an operator, what do? I need to do some math. Now we notice the order in which it has to happen. I'm actually taking the second pop minus the first pop. So this is 1 minus 5 is what I should be doing. Same thing was true. It was the 2 times the 4. But in that case, it didn't make a difference. But with minus, it does make a difference. All right, so I'm applying the minus operator to the top 2 things. And ultimately, it's the second thing that, well, it's the first thing I'm subtracting from the second thing. So this is 1 minus 5, which is -4, and I'm pushing that back onto the stack. Then I hit a 2, put a 2 onto the stack. I hit a 3, push the 3 onto the stack. Now I hit a power. All right, and what should I do with the power? Okay, so I hit a power here. What do I do with the power? Well, I'm taking something to the 3rd power. What is the something that I'm taking to the 3rd power? And this is kind of where the powers get a little bit weird here, right? Just like they were, we had kind of treated them as a special case before. So I'm taking something to a power. I'm going to go ahead and store. Well, let's just ask the question here. If I'm sitting right here, do I know what I'm taking to the 3rd power? A power has 1 input, right? Something to the power. But I don't know what I'm taking to that third power because that's later on math. That makes sense? So I'm going to go ahead and I'm going to throw power on there. We're going to remember this is something we need to do soon. Okay. Then we hit another power. I'll throw that power on there. All right. Then we hit addition. Addition is not a power. We go back to here and we're seeing where did that addition actually take place? This took place in this beginning part. So now we need to look at how do I handle these powers? I saw in here that it's that -4. Where am I at here? It's the -4 that I want to take to the second power. And it's the answer of that I want to take to the third power. Now, we saw a few minutes ago that when we ran into the 1 and then the 5 and then the minus, we took 5 subtracted from the 1. So when we hit this first power, I'm going to roll back to that first time we hit a power. Operators say do something. A power requires 1 input. So what are we taking to a power? That 1 input, just like with my minus, is the 2 elements down. So pop, pop, we're going to pop 2 things off when we have an operator. But the first input to that operator is that second value. But what's my second input? Go back here. Let's see, what do I currently have? I have the 2, I have the 3, I have the power. So I'm doing something to the second power. What's the something? The something should be that -4. -4 to that second power. So how do we go from the first time we hit a power here to actually do that math right there, ignoring the 3? We don't necessarily know at this point in time that the next power is coming up next, because we're feeding off this output cube. From our perspective right now, the only thing we have to work with is we have something to a power. That's what that guy currently looks like. Now I know that the thing I'm taking to that power is -4. -4 to the second power. That's what this guy tells me to do. Does that make sense? So ultimately, I want my stack to look like that. That makes sense? That's what I want to accomplish here. How do I consistently go from this form with a power to get the right numbers? Well, in this particular case, if we just hard code it to this case, what are we doing? I'm actually doing 3 pops, right? So I have a power. I'm going to say pop, pop, pop. So I'll get the 3, the 2, the -4. And then what am I doing? I'm taking the -4 to the second power. So I'm going to actually create a second stack here. So you'll see how we'll use the second stack to accomplish this. Let's empty out this stack. And we'll use this second stack for doing other math operations too. When we pop things off, and you'll see the things will come off in the right order. Like when we do the 1 - 5, the 1 will actually be at the top. All right, so I just hit the power. So I'm going to pop, push 3. I'm going to pop, push 2. I'm going to pop, push -4. That makes sense? Now I'm going to do something to a power. What am I going to do to a power? I'm going to do 4 to the second power, which is a 16. All right, makes sense? As I just did the pop push stuff, currently my stack looks like this over there. So after I've done this, what do? I clear this stack, pushing everything else back on. There's the 16. There's the 3. So I cleared this stack. Now I hit my next power. What do I do with my next power? Well, I got to do a pop, pop, pop. So I'll push the 3. I'll push the 16. I'll push the 8. If we go back to this guy, what am I taking to that third power? I'm taking the 16. The result of that, I'm taking to the third power now, right? Which was our 4096. So here's my 16 that I'm now taking to the third power. Well, this didn't consistently give me the same thing, did it? I have this thing upside down. So what we need to do is we need to discover, how do I handle powers in a consistent way? Because powers were our special case in building our output queue, and powers are seemingly our special case when we're processing our output queue. So if we roll back here, get rid of this guy. And I'm currently looking at this, my stack for processing that queue. And I run into that first power. I need to figure out, how do I process that guy in such a way that I get this guy to this power. I want to get a 16 from this. What do you think? Looking at this, I need a consistent way when I hit this power. I need a consistent way when I hit that next power. Anybody have any ideas? Let me quickly go back. I mentioned a minute ago that we can use this secondary stack for all of our math, all of our numbers. So let's go back and look at and see if that reveals a pattern for us. So I'll empty it out. We'll process this again. I hit a number. What do? I push it. I hit a number. What do? I push it. I hit a number. What do? I push it. I hit an operator. What do? Well, it's multiplication. So we'll call it a normal math operator for now. So what do I do with math operators? I pop, push, pop, push. So I'll pop the 2 off of here, push it onto my, let's call it my do math stack. I'll pop the 4 off of here, push it onto my do math stack. Then I perform this math. So I pop 2 things. I'm performing the math. I'm taking 4 times 2. So I'm taking pop times pop, which gives me my 8. Now I'm going to go ahead and push it back onto the stack. You'll see why here in a little bit, but we'll push it back onto the stack. But now I've said I've done my math operation. So what do I do once I'm done with my math operation? I clear this stack. All right. So to clear this stack, I'm going to pop, push. Until this guy's empty. In this case, I only had to do it once. All right. So that was for this multiplication. Then I hit the 1, then I hit the 5. So since they're numbers, what do? We push. We push. Now I hit a math operator, a standard math operator. What do? I pop, push, pop, push. Pop the 5. Push the 5. Pop the 1. Push the 1. Now I do my subtraction. I pop minus a pop, which is -4, and I push the -4 back on. Okay. Now I finish my math operation. So what do? I clear my math stack. So I pop push until this guy is empty. So pop, push. So now I'm at my -4. All right. I hit a number. What do? Push. I hit another number. What do? Push. Now I hit that power. So the question is what do I do to powers? If we go back to our guy right here, is the power I'm currently looking at, is it this guy or is it this guy? They both look the same to us, right? But the last thing I just did was a 3. So this guy right here is actually taking something to the third power. This is taking something to the second power. So we need to decide, how can we use this math stack to deal with our signs, our powers? What would happen if I go ahead and I say, I see a power, so I'm going to go ahead and I'm going to push that onto the stack. And powers are something to a single thing. So now I'll go ahead and I'll pop push. One input to a power, right? Whereas subtraction and multiplication require 2 inputs. Okay, so 1 input to a power, so that's a 3. Okay. So now I read again. I get to now I don't have the information at this point. I have a single input, but I don't know what I need to take that power to the power. I hit my next power. What do I do with my next power? Well, I push and then I pop push. I still don't know what I need to do to the next guy. So now I get to this divide thing. I hit another operator. Now, before I can perform this math operation, what do I need to do? Before I can do a math operation, this guy right here, I didn't do my 4, right? I pop push the 3, done. Push this, pop push the 2, done. Hit the divide. So divide says I need to do a math operation. My math stack still has crap on it. Make sense? Still has stuff on it. So I can't do a math operation until this guy is cleared out. Now, if this guy has stuff on it, presumably I'm going to need the next value from here to be able to do that stuff. That's my input that allows me to trigger everything in here to ultimately accomplish this next step. Okay. Now we're going to roll back in a minute and see that we can actually do this exact same algorithm for the other things, because what we didn't do before is we didn't actually push the math operators onto our math stack, but we're going to see we could have. But let's just kind of go through the motions here. So I know that I'm going to need to pop push that -4 in order to process this division, because my math stack currently has stuff on it. All right. So now I can go ahead and perform the stuff on my math stack. So when I do math, what do? I pop 2 elements, -4 and a 2, and then I pop the operator, the thing I'm performing. What's the thing I'm performing? -4 to the second power. -4 to the second power is a 16. Push the result back on. Now I ask myself the question, is my math stack empty? Still got crap to do, not empty. So what do? Whenever I'm doing something off my math stack, I pop, give me my 2 inputs. So pop 16, pop the 3, it's a power. What am I doing with that power? I'm taking 16 to the 3rd power. Which is 4096. Okay, pushing that value back on there. So now this guy has a single value on it. As soon as my math stack has 1 value, that's my answer up to that point. I have no more math to perform from this math stack. So my math stack is done when its count is 1. Make sense? So what do? I pop, push. And this guy's just an 8, correct? That 1 was from a kick down thing, yeah. So I pop off here, push it back onto there. Now I go back. I've been trying to do my division, couldn't get to it because this guy had stuff on it. But now this guy's empty. So I can do my division. How do I do division? Well, I pop, push, 4096, 8. Now I'm going to go ahead and do what we should have been doing all along. We're going to push that operator on there. So now I look like this. All right. I ask myself, is the top of this a math operator? It is. Since the top of this is a math operator, what do? I say, I pop, this is what I want to do. And then I pop, this is what I'm doing it to. All right. So I'm taking this first element and I'm dividing it by the thing that I'm doing, the second element, which gave me, what was that, like the 6. That gave me this dude, which is a inconvenient type number, but it's fine. So we pop, did our division, got that weird number. My math stack has a single value on it. What do I do with that? I pop, push. And now I hit my plus. With a plus, what do? Let me ask a question here real quick. I want to actually back up for a second because I did it in reverse. We had the right number. I just want to make sure I'm doing it in the consistent way. We got the 2, we got the 3, we hit the power. So I'm going to be doing something to the 3rd power. So I put the power on, then I popped the 3. Then I got another power. I put the power on, I popped the 2. Then I got, then I hit the divide. This had stuff in it. Okay. Well, this is fine. Let's just finish the math here. So this was, and then we'll go back and consistently do it all along. Oh, I already have that number, right? I have that guy. This guy looks like this. I hit divide. So I'm going to push divide on here, which is, we did it the other order before. We put the numbers, not the operator. I'm pushing divide on here. Then I'm going to say, so I have my math I'm going to do on here. So now I'm going to push pop. I'm sorry, pop push. Then I'm going to pop push. All right, this guy has some stuff on it. What am I going to do with it? You know, I actually do think I was doing it right before. Sorry, let me just roll back. I did it right the first time. I read the divide from here. In order to do math, any kind of math, what do? I pop push. That gets rid of this guy. Then I pop push. That gives me this guy. And then I push the operator that I'm going to do. Now I can peek at my math stack and say, what is it that I'm going to do? Is it normal math, or is this that special power math? Since it's normal math here, I say, do I have at least 2 more elements on here? If I do, great. So I can go ahead and say, pop, that's the math I'm going to do. And I want to take, let me go here real quick. This is 16 to the 3rd power. That's the 0.00, blah, blah, blah. This is my multiplication. That's where my 8 comes from. Divide. I lost my 8. When did I lose my 8? Now this is what it looks like. I said the right stuff. I just lost stuff from my stack. So I hit my divide. What do? Pop push. 4096. Pop push 8. Push operator. Peek the operator. Is this stuff I can do? Divide requires 2 inputs. Do I have at least 2 more inputs? Is the count of my stack at least 3? The operator plus 2 more things. In this case it is. So what do? I take the 8. This is what I'm going to do, the divide. I'm going to divide 8 by 4096, and that's that number there. So I just did that math. I'm down to a count of 1. So what do? I pop push. So these are the numbers that should be on there. Then, so I've already processed the divide now. Then I hit the plus. So what do? The math operator, I pop push. I pop push. Push the operator. Peek the top of this guy. This is a normal numerical operator. Fine. Do I have at least 3 things on my stack since I just peeked? I didn't pop anything off. So I need 2 inputs to make plus work. But since I just peeked this guy, I need to have a count of at least 3. I have it. So what do? I pop. That's what I'm going to do. And I'm going to add the 3 to this guy. Give me that. Pushing the result back on. This guy has a count of 1. What do I do with it? Pop. Push. I hit the end of my output queue. This guy has my final answer on it, the 3 point whatever. All right, let's walk through one more time, applying that exact same pattern. Okay, that exact same pattern. We hit the 3, push. We hit the 4, push. We hit the 2, push. We hit the multiply. Multiply says pop, pop. So we pop, push, push the operator. So those two guys are off there now. I peek. It's multiplication. Do I have at least 3 elements on my stack? Do I have enough inputs? The answer is yes. So what do? I pop the, what am I going to do? Then I pop, 4 times 2, which is 8, pushing the result back on here. Is the size of my math stack 1? Yes. I'm done processing it. So I pop, push. Okay, so that got me up through this point. Then I hit a 1, push. I hit a 5, push. I hit a minus. What do I do with a minus? Pop, pop. So it's pop, push, pop, push. Then I push the operator. I peek. It's a math operator, a standard math operator, let's call it. Then I say, do I have at least 3 elements on my math stack? Yes. So I have enough inputs. So I pop. What am I going to do? I'm going to take 1 minus 5, which is -4. Push it back on. Does this guy have a length of 1? It does. So what do? I pop, push. Then I hit the 2, push. Then I hit the 3, push. Then I hit the power. What do I do with power? I pop once. Okay, so I pop, push. Here's my 3. Then I push my power. So now I peek. So I peek at the top of this. I say, what does this guy need in order for me to do my job? We need at least 3 things. I need this guy. Well, I need the next guy to this power. And I don't have 3 things. I currently only have 2 things. Correct? Can't do this math yet. So if I can't do the math yet, what do? I keep going. I hit my next power. What do I do with the power? I do a single pop push. Then I push the power. All right. I look at the top. I have a power. Okay. This is where our special case comes in. Do I have enough information to take something to the second power? I don't know what I'm taking to the second power yet, do I? Let me ask you this. If we have to the third power is 8. So I don't have enough information to get me this thing. A power, I said, requires at least 2 things. So let's assume that we're going to try. So I'm going to pop this and say I want to try to do something to a power. I pop, but I notice that one of these guys is a operator. I don't have the information to do it. So what do? Push it back on. Power 2, power 3. We know when we look at our math thing here, we know those are the things that will need to happen. I just don't have enough information to make it happen yet. I need to get that -4 over there in order to make it happen. Well, let me ask you this. Could I have, roll back when it looked like this. When I read in this second power here, so the first one I already got, I popped the 3, pushed the power, decided I couldn't do anything with it yet. I read in the second power. I noticed that this guy was not empty. Keep in mind, the only special case here is that this guy is, he's only ever not been empty when we hit powers. Is that correct? All other times he's been empty. We've been able to perform a math operation, get a final answer, pop, push the final answer off. This is the only time where he's not been empty. So I hit this other power. And then I have to say, well, what am I going to do to this other power? Well, what we've been doing is we pop the 2. And then we've been pushing this other thing in here. But since it wasn't empty, could we have had the special case where we popped a second time? If I go back to this state, I hit this guy and I say, okay, I hit a power. Is this empty? Because we're going to say under all circumstances, we can only attempt to do math with an operator if that's empty. Seem like a true statement? Only if it's empty can we attempt to do math. Fine. So then what am I going to do? It's not empty, so I'm going to keep cooking. So now I hit my next guy. Is this empty? No, it's not. So I'm going to pop, push, and then I'm going to go ahead and pop, push again. Only because it wasn't empty the previous time. This is the thing I want to do. Then I perform my operation. That gets me a 16. Pop, push. Now this guy still has stuff on it, but I can follow through. I'm not done because this guy, once I started doing math, I have to clear this guy. So now it's 16 to the 3rd power, which is 4096. Pop, push. Hit the divide. We've already seen this part. That gets me to the 0.001 thing. Then I hit the 3 in the addition. That gets me to 3.001. All right. So whenever we hit powers, we're going to need 2 elements. So we, in this particular case, we didn't have everything we needed to process the first time, but the second time we had to completely process. And if we actually had 3 powers in a row, we would have had to keep going. Okay, but only once we got our math did we have to process it. All right. So for your homework, and I'm going to actually make it easier for you. For your homework, what we're going to do is, I still want to handle parentheses though. Why don't we say for your homework, implement, process the output queue, but you can assume that powers don't exist. Just as powers were a special case because they're done right to left in our creation of that guy, we have to treat them as a special case when we're processing it. We just saw it's more complicated, right? For clearing the queue. So for your homework, you can assume that powers don't exist. So you can assume that something like this isn't allowed, and you only need to be able to handle that. The algorithm for making it work actually isn't that bad. but it is backwards to the pattern that goes to everything else. All right. So for your homework, you should be able to handle things as complicated as that for processing the output queue. Make some sense? So you won't have to handle the special case. All right, questions, comments, concerns, bribes. All right, I'll see everybody on Friday. Oh, I gotta actually hit save. So I'll actually update the code in here when I put it up. And this should give us the correct guy here.